All right, today I'm going to talk about arc length. I'm going to show you how a formula is derived. It's a formula that you're not expected to really derive for the AP test. You're just supposed to know that it's out there. It's the formula for arc length, and it's specifically when you're defining a function y is some function of x. Okay, we're going to get into parametric equations later in the month, probably, and there's a different formula for that. So that's when things are defined like as y sub t and x sub t. But anyways, this is for specifically functions where y is defined as a function of x. Let's take a very basic example. Let's say I just wanted to find the length of the curve between a and b. Well, one way I think the word is crude you hear usually with this estimation. I can make a basic estimation just by saying it looks kind of like a triangle. And what does that triangle consist of? Well, I'm going to call this the horizontal movement, which is dx, and that's the vertical movement, which is dy. And so let's say this is L, and I'm going to say L is equal to the square root of dx squared plus dy squared. And then I can say, well, what is dy? Well, dy is the horizontal movement. But since this function is continuous, I could find a function that has the average slope somewhere in there where the tangent line is parallel to the tangent of the average slope. And I'm just going to call that f prime of x star, and I could multiply that by dx. And you might be like, why would I do that? That is a good question to ask. I don't have an answer for you other than it gets us where we need to go. Okay, so this is, now I'm going to call this dx squared plus f prime of x star squared times dx squared. Okay, and then now you can I could call this 1 plus f prime of x star squared times dx squared. All I did was factor out the dx squared. And actually the square root of dx squared is just dx, so now I could call this the length is equal to 1 plus f prime of whatever that magical x, where the tangent line is parallel to the average slope, times dx. And then you could probably see this coming, that I don't want to use a crude estimate. I want to be more precise. And so I could actually calculate this as two different lines like that. And the more of those that I get, the closer to an accurate estimate I would be doing. And what would that actually look like? This would be the L would equal the limit as n goes to infinity of the sum from n equals 1 to infinity of the square root of 1 plus f prime of x star star sub I squared times dx. And if I picked two other points, it would look like kind of it's the sum of all these different lines as you approach infinity is going to equal that curve. And you've seen this summation connected to the integral before. What is this equal to? L is equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. And this really is what you need to take away from this. You can write it down, take a picture, or put it in your notes somewhere. When it comes up, you'll need to know that it's there. When you take the AP test, you'll need to have it committed to memory so that you can access it there. And that's essentially the lesson for today. And then the techniques become knowing how and